Now this circuit contains a capacitor, two resistors and a battery. Initially circuit is open, that is there is no current inside the circuit. At t is equals to 0, this circuit is closed. We have to find potential difference across this capacitor as a function of time. As a function of time. Now you may remember formula Q is equals to CV, where Q is the charge on capacitor, C is the capacitance, and V is the voltage across the capacitor or potential difference across the capacitor. So we can write the same formula, V is equals to Q by C. That is, if I can calculate charge as a function of time, we can calculate potential difference as a function of time. So our task is to calculate charge as a function of time. Let us redraw the circuit. We have two resistors, resistance is R, and we have a capacitor, capacitance is C, and battery EMF is I. Let us say battery sends a current of I, and when this current reaches here, it is divided into two parts. Let us say this part has a current of I1, then this part will have a current of I minus I1. This is because Kirchhoff junction rule says total current coming at a junction is same as total current flowing through the junction. So this means current coming is I and current going is I1 plus I minus I1, that is same as I. Now this part will have a positive charge and this part will have a negative charge. This is because this is the direction of positive charge. So this plate of capacitor will have a positive charge and this plate will have a negative charge. When current reaches here, from this side we have I minus I1, from this side we have I1. So this branch of circuit will have a current of I, that is I minus I1 plus I1, that is equals to I. So finally battery gets a current of I, that is battery remains neutral. The same amount of current is given by the battery and finally same amount of current is taken by the battery, that is battery remains neutral. Now let us say at any time t, capacitor has a charge of Q. So Q is the charge on capacitor at any time t. On time t. So let us say we have three unknowns. I is unknown, I1 is unknown and charge Q is unknown. So we need three equations to solve these unknowns. Basically we can write three equations. One equation we can write in this circuit, another equation we can write in this circuit, and final one equation we will have, that is I1 is equals to dq by dt. Let us write one equation in this circuit. So we can start from here. So if I pass through this battery, we will have a positive sign because final potential difference is higher than the initial potential difference. So we will have Xi, and this side I am going in the direction of current, so we will have minus I minus I1 into R. Here also I am going in the direction of current, so I will have minus sign I into R, and this is equals to 0 because I am completing the circuit. I am coming to the same point from where we have started. We can write the same equation, Xi minus 2IR minus I1R is equals to 0, or from here we can write I 2IR is equals to Xi minus I1R, or I is equals to divided by 2R. So let us say this is equation 2. We can write third equation in this circuit. We can start from here. So I am going from positive to negative. So there will be a negative sign because of there is a potential drop, and potential difference across the capacitor is Q by C. So if I pass this capacitor, we will have a potential difference is equals to minus Q by C. Now there is no resistor here. If I go across this resistor, I am going opposite to the direction of current. So we will have a plus sign. And current is I minus I1 and resistance is R. So this is equals to 0. Now from here we can write minus Q by C minus I1R plus IR is equals to 0. Or we can write IR is equals to Q by C plus I1R. So this is equation 3. Now we can plug the value of I from equation 2. I is nothing but Xi minus I1R, and this divided by 2R. So what I am doing, I am putting the value of I from equation 2 in equation 3. So we can write this is coming from equation 2 and 3. R cancels out, so we will have Xi by 2 minus I1R by 2 Q by C plus I1R. So let us take I1 one side. So this becomes I1R by 2 plus I1R, and that is Xi by 2 minus Q by C, and this is 3 I1R by 2. Now we can multiply by 2, so we will have Xi minus 2Q by C is equals to 3 I1R, or we can write Xi C minus 2Q divided by C is equals to 3 I1R, or I1 is equals to Xi C minus 2Q divided by 3R C. Now we have to integrate. If I use equation 1, that is I1 is equals to dq by dt. So we can write here dq by dt is equals to Xi C minus 2Q divided by 3RC. So let us separate the variable. So we will have dq by xi c minus 2q, and this side we will have dq by 3rc. Now we can integrate both sides. At t is equals to 0, there is no charge on the capacitor. At t is equals to t, let us say charge is q. So integration will be ln xi c minus 2q, and we have to divide by the coefficient of q, that is minus 2, and limit will be from 0 to q. And this side we will have t by 3rc, and limit will be 0 to t. So now I can write ln xi c minus 2q, and limit is 0 to q, and this 2 go this side, so we will have minus 2t by 3rc, 0 to t. So we can plug this limit, so we will have ln xi c minus 2q, and when this is 0, this will simply become xi c, and this is minus 2t by, and this is 3rc, not 2rc. So now we can calculate q from here, that is xi c minus 2q by xi c, and this is equals to e to the power minus 2t by 3rc. So from here we can calculate xi c minus 2q. This is equals to xi c into e to the power minus 2t by 3rc. Or we can calculate 2q. This is equals to xi c. If I take common, then I have 1 minus e to the power minus 2t by 3rc. So from here we can write q is equals to xi c by 2 into 1 minus e to the power minus 2t by 3rc. So potential difference across the capacitor will be q by c, that is V, potential difference across the capacitor, that is xi by 2, 1 minus e to the power minus 2t by 3rc. So one can find this result by writing equations and solving integration.